This is the sun, and as you may know, it provides energy to all the planets that orbit it. But how exactly does it create so much energy? Well, the sun, like other stars, relies on the fusion of an insane amount of nuclei within its core, which sits approximately 139,000 kilometers deep. Within the sun's core, nuclei such as hydrogen overcome the natural repulsion and undergo fusion, fusing into deuterium, which will eventually collide with another hydrogen nuclei to fuse into helium-3, which eventually will collide with another helium-3 nuclei to form into helium-4. The result is a nucleus that weighs slightly less than the hydrogen molecules that make it up. The lost mass was converted into energy, as Einstein's famous E equals mc squared equation tells us that mass and energy are two different forms of the same thing. To us, this energy is the light and heat we receive from the sun. Now you might be wondering if we can replicate this here on Earth, and the answer is yes. Scientists and engineers are working to create reactors that can sustain fusion reactions for long periods of time. Now, due to the fact that the Earth's gravity is weaker than the sun, we must rely on temperatures up to 100 million degrees Celsius instead of 15 million degrees Celsius, as well as fuels that fuse easier, such as deuterium and tritium. This makes containing it even harder due to the extreme temperatures. However, since at these temperatures gases can become plasma, we can rely on the fact that magnetic fields can repel plasma and use magnetic fields to keep the plasma away from the walls of the container, which we call a tokamak. After this, we can use the heat or the pressure generated by the fusion reactions to generate electricity. While we don't have long-term fusion yet, our pursuit of it brings us closer and closer to a future with clean energy.